Okay, today we're going to be looking at section 5.6, which is dealing with parallel and perpendicular lines. So hopefully by the end of this section, you will be able to say, I can determine whether lines are parallel, perpendicular, or neither. And I can write equations of parallel lines and perpendicular lines. So again, parallel lines would be like these two over here, where we have lines that do not intersect. And if we look at the other one, we'd be looking at perpendicular lines over here. Okay, so let's take a look. First of all, if I wanted to graph this first line, hopefully we can do this in slope-intercept form by now. So I would be looking at a y-intercept of a 4 and a slope of a -3. So I go down 3 and over 1, down 3 and over 1. If you want to work backwards, you'd go up 3 and up 1. So you'd have this line right here. Okay, if I were to graph the second one would be a -2 for a y-intercept and a slope of a -3. So I'd do this here, and I'd be able to graph the line like so. And hopefully we can see that these two lines are parallel. And if we take a look, how could we tell that? By looking at their equations. So if we were to take a look at their equations, we should be able to see that their slopes are the same. So what does this tell us? That for for parallel lines, the slopes are the same. So that's a huge deal. Parallel lines. And this should be in a note now. Parallel lines, same slope. And the other thing we should notice, that they have the same slope, different y-intercepts. Different y-intercepts. Okay, so if we look at the next slide here, so let's graph these two. Hopefully we can do it again in slope-intercept form. So I got a y-intercept of a -5, 2/3, so I go up 2 over 3, or I go down 2 and back 3, and I'd end up with this line here. Okay, if I look at the next one, got a y-intercept of 1, slope of a -3 over 2, so I go down 3 over 2, down 3 over 2, or up 3 and back 2, and I'd end up with this line right here. And hopefully we can notice by looking at these that these two lines we would say are perpendicular. So what can we tell by looking at the equations? Well, if you notice, the slopes are related. One of them has a slope of 2/3. The other one has a slope of a -3 over 2. So hopefully we can see that they are negative reciprocals. So they're negative or opposite of one another, and they are reciprocals. So these two phrases will be used. So you should jot in your notes, perpendicular lines, slopes are negative reciprocals or opposite reciprocals. Okay, so we're going to use that fact to look at equations now to determine if they are parallel, perpendicular, or neither. So the first thing we have to do, we have to have two lines where we can, or two equations where we can determine slope. So this first one I can tell, obviously, that the slope is a -5 because it's in slope-intercept form. The second one, I would have to minus a 5x, and I'd have y is equal to -21 minus 5x. So my slope of this one is a -5. So we should have seen in this last couple slides here that if the slopes are the same, we see that these are parallel. And how could you explain it? Well, the explanation would be that they have the same slope. Okay, if we take a look at this one below it, if I wanted to take a look at this one, the slope of the top one is obviously a -4 because it's in slope-intercept form. The bottom one, I'd have to do a little work. I'd have to add an x, so I'd have 4y equals 14 plus x. If you divide by the 4, you'd have y is equal to, I believe it's 3.5 plus 1/4 x, since this is 1x. So my slope of this line is a 1/4. So I got a slope of 1/4, I got a slope of a -4. Those two lines there are going to be opposite reciprocals, so these are perpendicular lines. Okay, this next one, we have one that is an x equals, one that is a y equals. So hopefully we know that if I have an equation of a line that's an x equals is going to give me a vertical line. A y equals, hopefully we can see that a y equals is going to give us a horizontal line. So anytime we have a horizontal and a vertical line, these two lines would be perpendicular. Okay, so if we look at this next one, slope of the top one is a 6/7. Slope of the bottom one is a -6/7. So do they have any of the qualities that we need? They're not the same, so they're not perpendicular. Or excuse me, they're not parallel. They're not opposite reciprocals, so they're not perpendicular. So we would have to say that these are neither. Okay. Next two things. If I wanted to write an equation, slope-intercept line of a line that passes through the given point and is parallel to the graph of the given equation. So we have a point. We got a line. Our new line is going to be parallel to this line and goes through this point. So what do you know about parallel lines? Parallel lines, we know the slopes are the same. So the slope of my new line has to be a -3. So if that's the case, I've got a slope and a point. And if you remember, point-slope form is a very easy way to write an equation to start with if you have a point and a slope. So if I wrote the equation in point-slope form, it would be y minus 6 equals a -3 times x minus 2. Okay, so then all I have to do is get that into slope-intercept form. So how do I do that? A couple things. You first have to distribute. So you'd have a y minus 6 equals -3x plus 6. And then two things got to be moved. You got to add a 6. So now you got y equals -3x plus 12. And then you, well, I guess, never mind. That is in slope-intercept form. So we're done there. Okay. The next one, similar question, but now it says, write the equation of a line that passes through the given point that is perpendicular to the graph of the given equation. So now I've got a line, and now it has to be perpendicular and going through this point. So perpendicular, you should be thinking opposite reciprocals. So the slope of this line is -3. So my new slope has to be the opposite reciprocal. So my new slope would have to be a positive 1/3. So then I've got a slope here, slope here of a 1/3 and a point here of 6, -2. So if I put that back into point slope form, you'd have y plus 2 equals a 1/3 times x minus 6. And then all I have to do is rewrite that into slope-intercept form. So I distribute, and I'd get a 1/3 x minus 2, and you got a y plus 2 equals this. So then I just have to subtract off of 2, and you would have y equals 1/3 x minus 4. Now, you may have to look back at these videos a couple times to remember how to do things, but I think the process is pretty straightforward. Okay, so I don't know what the graph there was for, but we are done. So that is a wrap.